So our our sun is a star. It's a very special star to us, but it's a kind of a typical star that is a member of the Milky Way galaxy. So you might be wondering, well, how many other galaxies are there in the universe, or the universe as we know it, or our universe? And actually, you're not the only one to wonder that. So what they did, among other things, to kind of look at how many galaxies there might be out there, is to take Hubble, the telescope that's in orbit about the Earth, and to look at a place that there's nothing. So Hubble stared at nothingness. And actually, this is one of the videos for this chapter I have in my playlist. So I don't know if you recognize this region of the sky. This is the Big Dipper. Here's the handle, and here's the bowl of the Big Dipper. And this is where I'm going to show you, we're going to look at a photo here, and that's what Hubble saw when it looked there. So if you take that region and look closer and closer, and this is what you see, where this last photograph I showed you, and we're going to be looking at this in the next few slides, these lights are actually disks or blobs of stars that are assembled in what we call galaxies. So these represent galaxies in the nothing part of kind of the bowl part of the Big Dipper. Isn't that neat? Okay, so there we go. That's what Hubble saw. And so we use the word cosmology or I'm going to use it anyway, to kind of say it's the organization or the overall structure or the evolution of our universe. And a big important unit of matter out there is what we call galaxies. So galaxies contain billions of stars, and there's different types of galaxies. So, different types of galaxies, just to kind of get you started. We've talked about spiral galaxies, and I think I mentioned that our galaxy, the Milky Way, is a spiral galaxy, but we believe it's a barred spiral galaxy. And another important type of galaxies are called elliptical galaxies. They're kind of, we're going to see, they look more like a football, and they don't have much disk shape. Or excuse me, they don't have much disk. They're basically, they have a lot of halo. And then there's kind of a catch-all galaxy, irregular galaxies. We're going to see that, like, as we look at really old galaxies that were created a long time ago, some of them kind of take on this shape. The other reason I think that galaxies can kind of be irregular like this is that they've had run-ins with other galaxies. They kind of get beat up. So this, I think, is a figure that we looked at in the previous chapter, basically. What you're looking at is kind of a face-on version of a spiral galaxy. And just to kind of remind you, we have the disk region, where the stars are a variety of ages. We definitely have young stars here. We have the halo region. We talked about the Milky Way in the Milky Way galaxy, the halo has old stars, some globular clusters, dark matter. And then within the disk, we have these spiral arms. All to say, in the center, that bulge region, sometimes called a nuclear bulge, is a supermassive black hole. There's a spiral galaxy. This is looking at a spiral galaxy not face-on, but edge-on. So kind of highlighted there would be the disk of it. You can see the supermassive black hole in the center there. The halo part, now we've been calling it a halo region above and below the disk, and I think I introduced this term before, spheroidal component, and halo region is the same thing. So this again is a spiral galaxy looking on, it's not edge on but face on now. Just beautiful. And we said that in the halo or spheroidal region, we have older stars. In the disk, we have stars of an assortment of ages. Okay, so now this is a spiral galaxy called a barred spiral. And you'll notice what's different about it is, if you look for its bulge, its nuclear bulge, it is actually kind of elongated into a bar. And then it has two major spiral arms kind of extending from that bar. And we believe that the Milky Way galaxy is a type of barred spiral galaxy. And here's a look at a type of galaxy called a lenticular galaxy. And we think that lenticulars are kind of maybe a segue, like this says, an intermediate between spirals and ellipticals. Here's a bunch of elliptical galaxies. Elliptical galaxies tend to be older stars. Here's an irregular galaxy. Looks irregular, doesn't it? Looks like it's been beat up a little bit. And Edwin Hubble actually, this scheme is named after him, but we have a way of kind of looking at classifying galaxies into either elliptical, spirals, or barred spirals. And so if you want to put a star on this slide, I tell students in my class you might want to do that because in this one figure there's a lot of information. So we use the letter E to indicate it's an elliptical galaxy. Now the thing about elliptical galaxies, they're kind of globular. Okay, notice down here it says the spheroidal or the halo region dominates versus the disk. And it tends to change in its being kind of oval or round. So we use the sub 5 for being kind of more oval, the sub 0 for being rounder. So those are elliptical galaxies. Then we have the spiral galaxies kind of face on. And then we have barred spirals kind of face on. So notice that in both cases, spirals and barred spirals, we have these spiral arms where kind of highlighting these bunches of stars in these arms. And an important thing, oh, by the way, in spirals and barred spirals, abbreviated S and SB respectively, we would say instead of the halo or the spheroid dominating, we would say the disk dominates. It's more like a frisbee. It is, but it isn't. And this last thing I kind of revealed on the slide says that from right back to left again, and notice that spirals and barred spirals have a subcategorization of little c, little b, and little a. So from right back to left again, I don't know if you can tell, but the arms become more and more tightly wound as you go from C to B and B to A. And if we could look at them like edge on, what we would see is that bulge in the center where the supermassive black hole is, that as the arms become more tightly wound, like A, then the bulge would actually get larger. So that's why this trend here, that the subclassification of the spirals and the barred spirals of C, B, and A, it says that we get a larger bulge, a larger bulb and more tightly wound arms. So just to kind of, I don't say a lot about it this semester, but it is so interesting how galaxies are organized. So again, we're looking at, this would be, I believe, a photograph of galaxies out there. And they are first organized in what we call clusters. I know I have the word groups up here, but if you want to mark through that, say galaxy clusters, that's what it is. Very pretty. And wow, is that crazy or what? These lights, then most of these lights, as you're seeing them, would be galaxies. Specifically, this is now a cluster of galaxies, elliptical galaxies. And elliptical galaxy clusters can get very, a lot of members, a lot of galaxies in these clusters. And clusters of galaxies are further organized in what we call superclusters.